How's it going, everyone? Welcome, Eulio Gonzalez here, and today let's going to explore about the lexical scope. To make a quick recap of what it is, and then move on to the specific corner cases with the lexical scope. Why we need to use is now the strict mode as a way to help us cover is more of those elements. And also, we're going to look now at the difference between function expressions and arrow functions. So, because this is a course taught by Kyle Simpson, shout out to Kyle Simpson, absolutely, absolutely. And here we want us to understand now JavaScript. In other words, ECMAScript in its root, in its fundamentals. So according to Kyle Simpson, we have three pillars. We have the type system, something that we looked in previous videos when we went over the primitive value as well as the object, and also is the way of how you can get the value of this primitive, and some corner cases of that, such as null. What happens when you want to get the type of null and why this gives you an object, and also is the special cases such as positive and negative zeros and nan, right? And what this is being used, for example, to indicate movement, positive and negative, whether it's lateral movement or up and down. And the nan is to represent is when something is not a representation of a number. In a brief recap of the type of emptiness that we need to understand here, right? So for example, like undefined, undeclared, and uninitialized. And well, some exercise to understand now more about the type system, the values that we get with the type system, get ourselves familiar with the ECMAScript spec when you need to read that, when you read the type of operators, and understand some other corner cases like, as I mentioned before, the type of null that gives you now an object and why is the reason of that, and then the numbers, specifically the 0.1 plus 0.2, and why this gives you now 0.3, The TLDR is that because 0.1 and 0.2, they don't give you an accurate representation of a number in the binary systems. So therefore, because we have now limited memory, the computers, when interpreted or compiled your code, it round those numbers. So giving you now is the 0.3, a representation in decimal point that is not accurate in a rounded by this binary rounded at the binary level, but in a binary system. So in other words, because we cannot represent accurately in decimal 1 divided by 3, because they give you now this, so divide 1 by 3 and they give you now 0.3, 0.3, 0.3, 0.3, 0.3, and doing because of this lack of accuracy, giving our hardware constraint, which is a hardware limitations, well, that's the reason why we actually look at this, and also why the alternative is to use some decimal libraries that help you to handle this, or round those numbers, or get you only the two decimals from that. So good with these corner cases, because then we move on to the abstract operations, And now these abstract operations is something that is common in JavaScript, and this is just a conceptual algorithm that is running behind the scenes when something is needed. So for example, when you want to coerce or to transform, uh, in this case, from a type from another one, right? To do this, these abstract operations indicate is the transformation of this. Let me actually, because I'm not quite sure of that. But even though the abstract operation is this, so these operations are not part of the JavaScript language, and they are defined here solely to aid the specification of semantics of the script language. Other more specialized abstract operations are defined throughout this specification. But in order to facilitate their use in multiple parts of this spec, some algorithm, it's an algorithm called abstract operations, are named and written in parameterized functional form, so they may be referenced by name from with other algorithm. So in other words, it is algorithm. Right? So abstract operations are typically referenced using a functional application style such as operation name, argument tuner. Some abstract operations are treated as polymorphically dispatched methods. And when we talk about this polymorphic, is that giving a specific input, it can give you now multiple outputs. That's what the polymorphic sees. So if we ask Claude about that, from this, right? So from the ECMAScript spec, so it is safe to say that polymorphic dispatched methods of class-like specification abstractions, such as method-like abstract operations, are typically referenced using a method applications. So polymorphically dispatched methods, polymorphically dispatched methods, right, is a function, all right, or an algorithm that give you different outputs given the same input, all right? So it's not pure functions. I will say that it is, because sorry, that's not quite right. Polyformically dispatched methods don't give different output for the same input. That will make them unpredictable, a break fundamental assumption of how functions should work. What polymorph? Okay, that's right. Okay, what polymorphically dispatched mean is that in that same method can behave differently depending on the type of the object it is called on. Okay, so poly poly polymorphically dispatched methods means, okay, dispatched methods means that the same method, okay, the same method, the procedure, which is different, the same procedure can give or can behave differently depending on the type of object. So the same method can behave different depend on the type object. Okay. So the key insight is that the object itself is part of the input. Exactly. So you're not given the same input. You're given the same method, name parameters, but different receiver objects. So in other words, so polymorphically dispatched methods means that uh, given different given different inputs or types, it behaves differently. Okay, given different inputs type will produce different outputs. Okay, so polymorphically dispatched method means that given different input, specifically different types, you will get different outputs. But they're gonna pass through the same method. So polymorphically dispatched method means that given different inputs will produce different output by passing by passing through the same procedure. Okay. So given different inputs that pass, given different inputs, the procedures behave differently. The procedures behavior will produce different outputs. I think this is a more accurate way to describe this. Exactly. So polymorphically dispatched method means that given different inputs, the procedure where those input path behaviors will produce different outputs. All right. So an example of is the same method called like value to string will execute completely different code path, follow different algorithm procedures, and produce type appropriate results. In other words, this doesn't make it unpredictable. It's just now behaving accordingly to the input. That's why you have now this undetermined quote quote undeterministic behavior with the double quote quote. But in any case, is so for example, the loosely equality. All right. So for example, loosely equality is a good example of, as well as other methods or other algorithm as well. Let me look at that. Loosely. Oh, come on. Asterisk operations. Asterisk operation, no, but it is more like testing comparison. Is loosely equal. Is loosely equal. So for example, is loosely equal, right? Exactly. Which is that same time often does a strict equality checking, number a string converting to a string then compares, Boolean and anything converts Boolean to a number, object and primitive call the object to primitive methods, and null and undefined special case are considered equal to each other but not anything else. There is also something that you didn't cover, which is big int. Big int with a string, it coheres that to a string. All right, you need to consider that. So when it comes to do that, to n, So for example, like this, 2n is equal to 2 is true, or as a big int, or even as a string as well, you know. So that's the idea behind these polymorphic methods. Uh, and again, you may wonder, is like, why do we even care about this? Right? Why do we even care about this? Well, because these abstract operations, these algorithms, uh, which are written in this way, all right, is the foundation to understand the behavior of one of the most controversial syntax in the language, which is the double equal, right? A lot of people say that, no, I'm not gonna use that because I'm gonna ditch that, so I'll be safe if I don't use that. Or following is some concept from Doug uh, Crawford, Doug Crawford, right? The creator of the JSON, which is mind blowing. It's mind blowing that he's still alive, and I like it. Absolutely, yep. I absolutely like it that he's still alive. Yep. And um, Peter Thiel, why? What the fuck? Did he die? Oh my god, what the fuck is this? Um, what? Okay. You don't want to show me that? Uh, there is no image for that? Okay, there is no image for that? Wait, what the But why they don't show the photos? Like, okay, 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 okay. Mm-hmm. This is interesting. It is interesting how now that enter into the realm of social aspect, you know, of social aspect. Of social aspect. Oh, here we go. In a sudden development to come 2 weeks after Thomas 35 was found dead from an apparent suicide outside His Miami, Florida apartment. Oh, crap. And Thomas first met sometime in 2015, 2016 at Coachella. Shortly thereafter, they began a relationship that ultimately end just a few months before the 35-year-old model and influencer is believed to have taken his own life. This is currently an outspoken supporter of Donald Trump, and the 50-year-old has regularly come under fire for not only donating on Trump's campaign, but also the campaign of the anti-LGBT candidate. Oh my god. Okay. Okay. Yeah, it's part of the narrative, bro. But in any case, it is quite interesting. It is very quite interesting. And I know that we take a long shot. I know that we took a long shot. We we took a long shot. But the TLDR of this story, okay, especially when you combine the technique with the reality, with the logos, with the psyches of the human, is that at some point, this has a no match here. You are going to deal with that. So especially if you are, I don't know, gay, or you are not considered straight, um, I wish you the best. I wish you the best, because everything is inside of us, and I prefer to be honest. I'll definitely prefer to be honest here. Deadly prefer to be honest, especially when I'm going to relate to somebody, because relationships are just to exchange something. We like it or not, this is the way how we now interact with others. And not only with people, but also with these particular ideas or concepts. So, for example, understanding is this. This is the relationship that I having with the ECMAScript, and to understand that. So, and in exchange, I want this understanding. Why? Because now I can not only describe things better, I can understand the mechanism, and therefore I can provide the solutions or help my future self to eliminate or to cut a lot of time in trying to understand how these things work, especially if you're going to provide that as a service. So because of that, all right, so because of that, this is one of the reasons when you are entering into a relationship, all right, that the more you are clear with that, the better off will be for yourself. In other words, and I get it why a lot of this is not this is not me saying that I approve that kind of relationship. For example, that CEOs or any high performing individual actually are looking for this escort, all right, because there is a market, because there is this transactional uh, nature in ourself, okay. So no matter if you are a wife or not, or a husband, whether it's woman or man, both of them expect something, and not only for the relational, the mating, but also when you're going to learn something. you expect to get something out of this. And this is also true for a lot of young people that go into, or when they when their parents, or I don't know, the society or some aunts or some family members tell them to go to study, right? Because they are even suddenly telling them, hey, you need to go study because in exchange you're going to receive something that is valuable, quote, quote, into the market. And what happened is that a lot of kids out there, including myself, back in the old days, um, when we went through the school system and yada yada yada, and we learn all of this kind of stuff, we say that's great. However, I don't see any of these things applicable right now. And this is also true for where where people that live in ghettos and stuff like that, or in places where there is a lack of opportunity, or the only opportunity that they have is to work, right? What happened is that they see that working actually gives them something immediately, but at the expense of a long-term goals. And this is exactly what happened when you're trying to study something or to learn something, on whether it's a mechanical stuff or like the language itself, ECMAScript, or uh, in a more physical means, like a motorcycle or repairing stuff and so on and so forth. So the more you're doing that kind of stuff, all right, you expect something in return. This is why when I look at friendships and lovers and kind of stuff, is that as long as you provide me something of value and I can do that as well, we can have a relationship. But the moment that you stop providing me that, this is over. And I don't think this is wrong or bad. This is human nature. Where this come from? This come from ourselves. Perhaps the conscious, the universe wants is doing that, because there is something hidden that we need, that is inviting us to explore that, which is, hey, why do we even you find valuable things, and so on and so forth. So for example, like lingerie, in my case, what the fuck? So for example, like a woman in lingerie, right? What is that you find attractive on that? You know, what is the thing that you find attractive on that? Oh, what I find attractive is the curve, the boobs, the 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 V shape, how she looks like. And it's interesting because it's talking about our biology nature. Again, I'm just doing all of this, right? I'm just doing all of this. It's because at the end of the day, the most honest we are to ourselves in something, the better off will be for us as human. And also for women, what they are looking for, well, they are looking is for somebody that can provide. Is a competent, is intelligent and assertive, is bold, ambitious, and generous, and also is fit, bro. Fit for life. Jesus. Look at, I know I take a quick tangent here. I took a quick tangent here, but I did this because it all is related, right? Especially when you want to learn something, like the ECMAScript and the back, and yeah, like the ECMAScript and how this behavior works, to understand this. So anytime that you want to have a relationship, all right, the more straightforward, the more clear you are with it, the better off will be. And the better off will be is that the more, the more, the more, the more organic, and the more natural it'll come up. You know, the more organic and the more natural it will come up. And when things rise from this natural and organic, when things now exactly so when things now um when things are when things are organic, natural, from this blossom, uh that's when the true happens, and that's when now this kind of relationships becomes um become last longing. I don't have perhaps words to describe what is the next stage, all right? Because I might need to explore a little bit more words to that. But when you do this kind of stuff in an organic way, which is from the true, and the true here, especially in relationship, that this is a transaction. We expect something from somebody else, and they do that in return. So when you go out to the market and they hire you, so they expect you to behave and to act accordingly to certain expectation that they have. For example, from the employee relationship, they expect you to be competent, be intelligent, be assertive, be somebody that also is bold, ambitious, generous, that can solve and provide solutions, right? And they don't care about the physical aspect. But when you go to the dating market, they expect all of that plus the physical. And if you can provide that and the other person is something that you want to expect them to get that, then you will have now something. Then you can have this relationship. In this relationship, as long as they fulfill this, um, as long as they fulfill this uh, conditions in each other, they can now develop is a relationship. We also need to understand that we cannot always provide that, all right? And at some point, the relationship will end. So understand that nature, which is also something that a lot of ex-core they know very well. They know, they just only use the psychos, the psychology to actually grasp you and treat you in the way that you would like to be treated, so on and so forth. So they now are a performers, right? They are now a performer. They are now a performers. Yeah, that's what it is, man. They are now a performance. They are now a performance. Yeah, they are now a performance. Yeah, they are now a performance. Hmm. I respect the hustle. Absolutely. So in any case, now going back to here. Hmm. I respect truly the hustle, man. I respect truly the hustle, bro. I respect truly the hustle, bro. I respect truly the hustle, bro. I respect truly the hustle. I respect truly the hustle, man. I respect truly the hustle. I respect truly the hustle. I respect truly the hustle, man. I respect truly the hustle. I respect truly the hustle. I respect truly the hustle, man. I respect truly the hustle. I know that I stuck into that. And they put a value, man. And they put a value. 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 And they put a value, bro. They cannot handle it. That's mind blowing, bro. That's the mind blowing things of all of this. That's the mind blowing thing of all of this, man. That's the mind blowing thing of all of this. That's the mind blowing things of all of this. So, that's the mind blowing thing of all of this. That's the mind blowing thing of all of this. That's a mind blowing thing. That's the mind blowing thing, bro. That's the mind blowing thing of all of this. That's the mind blowing thing of all of this. So in any case, um, here we are, okay, and here we are to now understand well about what is this abstract operations. We know that at the end of the day, these abstract operations are just algorithms that do the polymorphic nature. You know the word. This is a fancy way to say giving a different input the procedure. All right. So giving a different input, the procedure behaviors will produce a different output. And this is now part of the core of this abstract operation or the coercion system, right? So once we understand this particular concept, we now can see clearly is the toPrimitive and what this actually is doing. Behind the scene is going to receive now a hint that wherever that hint is a string or a number, it will now invoke these two functions. For example, if this is a string, the toString method, and the other is the value of, or vice versa if this is a number. All right. Now, the other is the toString, which is going to stringify any primitive or object that is passing through. So stringification of primitive is pretty straightforward. Even though for the only caveat is the -0, okay? The other is the stringifications of arrays, where now the behavior is that if this is an empty array, I'm going to give you now an empty string. If you give now collections of numbers or elements, I give you now these collections in a comma separate value. If you pass now a null or undefined, I will give you now is an empty string. So for example, like this. If you say, hey, I want to stringify now is null, it will give you an empty string, or undefined, it will give you now an empty string, right? And the other is with the object. If you stringify now an object, it say, hey, this is what is going to transform this. You can now have access to this and change the value by using the toString operation, which is now an abstract operation, and to say, hey, the value of this object, let's say you have now, for example, here name, and this name is like this, say Euler, right? Or Joe. And then you say, hey, I want to now return is this particular value, let's say name, right? And you say, well, I'm going to return is now this, which to me is quite interesting, that it doesn't return that. That's interesting. That's interesting. Because this is a function that is going to evaluate this, and then now it gives you this. So inside of that function, you can define, we can get more fancy here, okay, and say, hey, for some reason, I want to have access to this another, let's say let, all right, and let's say let of name, let's say zip, zip code, zip code, and here you have an object, and this object you'll see is the postal, right? Something like this, and say now some number, random number, and then the city, for example, you have here as the Buenos Aires, right? Buenos Aires, okay, which is good. And after that, you want is to now return this, okay? You're doing this. Exactly. After that, you want to return is this, right? Cool. And then you say, hey, but I want to return a zip code. What do you think that it will be the output of this? And it's telling you they can convert object to string, because now it is the end of the change of this. But what you can do is to say, hey, zip code, I want to now coerce that into a single value as a primitive here. The same for city. So again, this is something that you're not gonna use a lot. This is not a development alternative to do this. It might be helpful for you to debug what's going on, especially when you see stuff like object, okay? To see, okay, I want to seize the value of this, but you're not going to see that a lot. So we went through the stringification of primitive, as well as arrays and numbers. In some corner cases, for example, -0 or the -0 values here, right? And then with the numbers, this is more interesting because it has more corner cases. One of them is the stringifications of numbers, all right? Anything that is not a valid representation of a number, well, it gives you now is a nen, all right? If you provide now a string that is if you provide, for example, -0 as a string, or +0, okay, or infinite, all right, which is a reserved keyword for that, or if you pass now null, which give you 0, or if you pass now undefined, which give you nan, what the you know, and not to mention that if you pass now an empty string and give you 0, this is where now the corner cases of this becomes quite well, problematic as you go on. So we look at the stringification or the numberification of a string, the numberifications of Boolean values, true or false, 0 to 1, the null and the undefined, all right, as well as the objects such as array. And here it's gonna give you now is a 0. If you pass now an empty array, it will give you now a 0. If you pass now an array with null, it will give you 0. If you pass an array of undefined, it will give you 0. It's supposed to give you now a nan, like undefined, but it gives you now is 0. Anyway, if you pass now values to this, it will give you now those values. If you pass now a collection of value, because that's not a value name, it will give you now name, all right? And the other is with, if you pass a big int, it will give you the correct representation of that. And when you look now at the objects, it will give you, well, as you might guess, what would you expect that this will give you? Not an object. So that's good. That's good. Now, with that, then I look at the okay. Yeah, then I look at the, how do you put it? How do you call it? Okay. Then we look at the toBoolean, all right? So any place where you use a value that is not a Boolean, when a Boolean is needed, this operation happens. So you have the if, you have the while, do while as well, all right? Any place that a Boolean value is expected is this. This is a more straightforward operation. It's a lookup table. You can check out the falsy values. Anything that is not a falsy is now a true t value. So we have now the false value, falsy values, which is undefined, an n, empty array, and empty array is true. So you have now undefined, nan, null, empty string, 0, positive, negative, okay, positive, negative, and false, of course. So we also look at the other operations such as the addition operator, that what this operator are preferred, what is the abstract operation here, it was the algorithm that's going on. So if one of these operands are now strings, it would prefer string concatenation, otherwise a numeric operation. Then we look at the special corner cases with these abstract operations. So for example is, well, with the positive and 0 negative, with the plus operator, as well as with the comparison operators such as 1. All right, so it will actually give you the proper answer. But if you pass now something like this, all right, which is 1 is less than 2, it is, but it's 2 is less than 3, it is, but 1 is greater than 2, it is. It's interesting because now it's evaluating exactly, especially when you use now with these string operators here, because what it's doing is that it's going to evaluate this and say, hey, is 1 is greater than 2, it will say true, yes, but true values becomes now 1, and therefore it say 1 is greater than 3, of course, is false. However, when you do these operations, and it says that 1 is less than 2, it is true, this becomes now true, all right? Because it is evaluating that expression to a Boolean, and this expression now becomes so 1 is less than 2, all right, it becomes true. It will go to coerce this and say that 1 is less than 3, if it is. There's some corner cases here that I want to cover here. Like types, course, understanding. Corner cases of coercion. But I think that exactly 3 is great. Exactly. The other is 3 is greater than 2, which is true, but it's greater than 1, which is false. And then you get this. It's like this is the corner cases that you're getting here, right? So the corner cases is with the comparison here. So 3 is greater than 2, all right? It becomes this as true, which is you're going to coerce that into 1, and 1 say is false because of course this is not true. So the idea of this is especially when you are analyzing Boolean expressions like this, you have to be careful because they are going to be coerced into a Boolean, all right? And your logic might or not be useful to go with. So this is the corner case that you're gonna see that. I really love to show this. some of the philosophy of coercion is that the TLDR of this section is that you need to be intentional about what you're going to learn and how you're going to learn. And that's one. Okay. And when you are going to write your code, it is important to be descriptive, be intentional about what this code does and how it does, and use comments to describe why you're doing this. All right, I think that's quite very powerful to understand that. And the other is that it's important for you to keep learning all of this kind of stuff, regardless what other people might say, or Douglas Crawford, the JSON co-creator, or the creator of a book called the because you say Douglas Crawford, the creator of JavaScript, The Good Parts book series in 2008. Holy moly. 14 years ago, god damn. 14 years ago, all right, he described that. The point of this is that you need to continue to push your boundaries and understand that as long as you want to be in this industry, and I will prefer for you, and this is my suggestion, that you dedicate to learn genuine things along the way. And this is also fun because as you learn this kind of stuff and you develop a intuition of what the things does and how this is working, you then started to have better problems. You then started to create now, for example, is a landing page and interesting stuff, you know. So yeah, that's quite interesting. So then we look at the another abstract operation, which is the testing and comparison object, especially the isLooselyeQual and the strict equality. The TLDR of this is that this algorithm, what it does is to walk through a series of steps that you can take a look at the spec here. Is loosely equal is loosely equal, that you can walk through this and understand what this algorithm is going to do. And it is pretty straightforward. It's not that hard to understand. Perhaps the way of how this describing stuff is in this numeric algorithm way, kind of like throwing you a brick. Okay, it's hard, it's painful, but as you get yourself familiar with this way of describing algorithms and in the spec along the way, you're going to get yourself familiar with all of this. So the thing here is that if they are the same type, return is called the strictly equal. All right. If they are null and undefined, or vice versa, okay, return true. So they are the same. However, if one of them is a string and the other is a number, do a numeric coercion to the string. All right. If the other is a big int and a string, or vice versa, okay, do a string coercion to the big int. If the other is a Boolean, with whatever position is, okay, do a numeric coercion. If the other is an object and the other is a primitive, whatever its position is, then do a primitive coercion of that object. All right. And this is it. And anything else, do a numeric coercion. All right. So once we understand that, we can now, for example, solve problems like the undefined is equal to empty, all right, which is false. So what it's doing here is say, hey, if one of them is a string, okay, and the other is a primitive, so if both of them are primitive, but they are not the same type, behind the scenes, if we remember, at the end of the day, it is going to do a numeric coercion. So in other words, it's going to transform this undefined. If you remember what undefined is, which is not a number, all right? So it transformed that into a not a number, and since empty string, okay, now is since empty string now is, do you know what is the empty string will tell you? 0, right? Okay, we'll give you 0. So it's now going to coerce this into like this. So it's not a number is equal to 0. You might expect the opposite, but here's when the spec is telling you about what is NAND and what is 0. NAND is the only value that is not equal to itself. So in other words, when you want to compare that NAND using the strictly equal, or the double, or the strict, or the triple equal, it tells you, no. They are the only values that by passing through these abstract operations are going to evaluate them as false. However, if we want to check if two numbers actually are equal to themselves from the semantic aspect, all right, we are now use the Object.is to solve with this incongruency. But again, this is for this special case. So if you use now, for example, undefined and then now 0, what you might expect, okay? You might expect now here is to be false, right? Because they are not the same equal type. You can think of this like quadruple equality, all right? You also can take a look at the Object.is methods of how that actually is working. Is evaluating now is the same value, it's calling to this same value primitive and returns a Boolean. It determines whether or not the two arguments are the same value. It performs the following step when it's called. If type X is not type X, type G, return false. So if they are not the same type, okay, if they are not the same types, you're gonna return false. If they are not the same primitive, you're gonna return false. So if you put now undefined, it will give you properly true. That's why it now with isName you can have now this true behavior of checking that. So this is the reason why when you use now undefined equals to 0, it gives you false. All right, because of this abstract operation, because of the algorithm, and there is no magic behind that. So the magic is like evaporate. So this value is now converts to a not a number, and therefore that's what we have here. However, what happens if we want to do now null? Is null will be behind the same? So with null, you will expect it to be is now false. That's interesting. That's a very interesting behavior, because this null, which is number, okay, but because you need to coerce that. So null is equal to 0. That's interesting. Okay, so null is equal to 0, and here we come in with the edge cases here. And here it comes with the edge cases here. All right. What if you compare now a null to 0 and say, hey, this is false. All right. So if we look now at the algorithm here, and if we check now anything related to a string or a number, okay, if G is null and G is undefined, return true. So if none of this is the case, all right, if none of this is the case that I mentioned before, all right, so if you now compare that to a big int, it will give you false. If you do that with false, it will give you false. If you do that with true, it will give you false. You know, even if you do that with an object, it will give you false. So because as long as they don't pass through this series of steps, okay, so by passing through this algorithm, it now gives you, it doesn't match any one of these cases, return null. So in other words, if you now surmount or cast null on a primitive, okay, if you want to compare now a null with another primitive, whether it's a string, okay, whether it's a string or a number 0 or 1, or a Boolean false or true, all right, or a big int, or an object, or an empty array, it will throw you false. And this will behave the same as the undefined. You know, this is an empty string, or this is a 0 or 1, or this is a Boolean, or this is an object with undefined as well. It will give you that false. So again, the behavior of this algorithm is predictable. It's not what you might expect, because if you don't read the spec, you will never understand this. So therefore, the idea is to get ourselves familiar with that. Understanding by reading is the spec, you can get a deep sense of that. You also have to be careful, because what the spec says sometimes is browsers don't have that implemented yet. All right, that's what you need to look at, if that feature has been implemented first in browsers. Where you can look at that, by actually look at the can I run? No, can I run it now? It's another website. Can I see it? Wow. Holy moly. Jesus. Can I? Jesus. Browsers support. You can look at the MDN. A more straightforward is take a look at the MDN. All right. Navigate down to whatever feature you want to evaluate. Let's say double equal. Okay, with strict equality. Navigate down to this, and see. You can see the how well supported is this feature, right? That's like the most strict place where you can take a look, and it's telling you now the spec of this, which is great. Even though it's telling you where they are looking to. So I think that most of the people never have clicked into the spec, because when they read this kind of stuff, it's like, what in the F is this? I get it. What in the F is this? So, knowing that loosely equality, strict equality, and also the Object.is, which is now checking if they are the same type. All right. And there is a concept here, for example, with the identity, especially on objects and arrays. So, for example, if you use what you might expect from the Object.is, okay, Object.is between array, what you might expect, right? To be the same type, right? If they are the same type, they're supposed to be true, right? The answer might be unexpected, because there is also a concept called identity, value identity, where now tuples or lists and objects are now falling into these specifications. So if we take a look now at the Object.is here, let's explore this. All right. Two values are the same if one of the following hold: both are undefined, both are null, both are true or false, both strings have the same leg with the same characters, both have the same object, meaning both have values reference the same object in memory, both are big ints, both are symbols, both our numbers are +0 or -0 or nan, or both are non-zero, not nan, and have the same value. Object.is is not equivalent to the double operator, and the double operators apply various coercion to both sides. If they are not the same type before testing for equality, resulting in such behavior as is the operator apply coercion to both sides if they are not the same type before testing for equality, resulting in such behavior as empty string is equal to false being true. Because what's happened here is I say, hey, I'm going to coerce that value here. What will happen here? It's going to coerce the value, the Boolean value, to a numeric operation, all right? These numeric operations that now have the empty string is equal to 0. When you have now a string and a 0, what it's going to do is to coerce that string into number. 0 becomes now, so empty string becomes now 0, and false is 0, therefore they are true. But Object.is doesn't coerce either value. And that's the subtle difference here. So Object.is is not equivalent to the triple operator, and the only difference between Object.is and triple is the treatment of signed zeros and non-values. The triple operator and the double operator treats the number's value -0 and +0 as equals, but treats non-nan as non-equals to each other. So in other words, what it's going to do is to check that even though it's telling you the language spec, where you need to look at that to get yourself familiar with. All right. So in other words, if what you truly care about is the type, you most of the time use this. So if both things are, if both the same objects, meaning both values reference to the same object in memory. In other words, here what we're saying is, let's take a look now at this. Okay. Let's take a look now at this. Yeah, let's take a look now at this. All right, and if they are not the same objects, in other words, when you look at the identity, value with identity, like this, right? this is when it tells you now some of the example of this identity, of this universally unique characteristic called identity, right? So values with identity are like values without identity, but with an additional, unguessable, unchangeable, universally unique characteristic called identity. Okay? Reference to existing values with identity cannot be manifest simply by describing them, as the identity itself is indescribable. So in other words, what is telling you that example of a specification values with a specification identity include, but are not limited to, any kind of records. And what is a record? It can be either is a list or a data aggregation within the algorithms of this specification. A record type value consists one or more named fields. The value of each is ECMAScript language value or specification. So this record type can be is an object. All right. Can be is now an object. So it can be now is a collections or an object, including property descriptor, private elements, among other stuff, right? So sets is also a different objects, all right? Relations, abstract closures are different objects. So for example, if you create now a closure and you want to compare that closures, it makes a lot of sense because at the end of the day, it has now a referencing memory for each one of independent, okay? Data blocks, private names, execution contexts are unique, all right? Execution context stack, among others. What are those with like this? The ECMAScript language value without a specification identity and without language identity are undefined, null, boolean, string, numbers, big int. Notice that they don't mention anything about nen. Okay? But if you want to take a look now at nen, have fun to read about that. But this is the TLDR of this. We also went through describe is the benefit of the static typings. This is my intent of this is not to get ourselves familiar with TypeScript. It's just to describe what TypeScript is and what is the type system. This is static type system that is going to now do this static analysis of your code. There's some benefit of that, which is you can now catch type errors at compile time. You can now communicate the intent of your code much more clearly. And now a lot of the ID provide is this auto completion feature or these intelligence features that I really love and everybody loves. So the caveat is that inference is best get. It's not a guarantee. The annotations are optional, and any part of the application that isn't type introduces uncertainty. So this is part of the trade-off of that. So now with the scope, but the TLDR of this is that I make a quick recap of at least the type system, one of the pillar of JavaScript. And on the next video, we're gonna explore more about is the other pillar, which is the scope and the scope analysis. So that'll be all for this video. Take care. Bye-bye.